sorry. Okay, here we are. So in the GREENART project, we start with three main objectives. So the first one was firstly to guide the step-by-step the design of safer solution for both human health and the environment. And secondly, we had this goal to develop a screening sustainability assessment in order to identify the most promising solution among all those proposed within the GREENART project. This was quite challenging because right now we have a lot of methods and tools to assess sustainability, but it's quite challenging in the early stage of the design phase to apply those methodologies. So we try to build something of more simpler to apply. And finally, we had to compare this innovative solution with the established technologies because we need reference to understand if our innovative products could be better of what we can find already in the market. So another challenge was to assess all the different products that are proposed within the GREENART project that you can see here, and you will know more about it in these 2 days. So in order to reach these 3 main goals, we try to start with something that was already established by the European Commission and in particular by the Joint Research Center. It is called the Safe and Sustainable by Design Framework. It is a guideline that propose an approach in 5 iterative assessment steps. So we have step 1 for the hazard assessment of the intrinsic hazard properties of chemicals and materials. Step 2 for human health and safety aspect in the chemical material production and processing phase. A third step for human health and environmental aspects in the final application phase, and this phase is quite important because it's where you are involved, these are the final user of those products. Then we have a step 4 for the environmental sustainability assessment, and later we'll know more about it, but it's based on life cycle assessment methodology. And finally, a step 5 for social and economic sustainability assessment. So those assessments are quite challenging to assess because we do not have established methods. So it's an additional, let's say, step. It is important to remark that when a producer start to design a new products, of course, he takes into account the design principles that are based on green chemistry, green engineering, and so on. But the European Commission is really pushing to use established methodologies to assess sustainability, because if you want to claim that a product is safe and sustainable, you should, of course, declare it and using the right assessment. So this illustration is about the GREENART approach that, as said before, is tried to simplify the safe and sustainable by design approach. So we developed 3 stages of assessment. Stage 1 that involves an hazard assessment, stage 2 the screening sustainability assessment, and finally the life cycle assessment and life cycle costing. As you can see, in the first stage we assess a lot of solutions, all the solutions that were proposed at the beginning of the project. So we assess a lot of ingredient mixtures and so on. But then, after the assessment, and we will know more about it later, we select the most promising solution that were then assessed in stage 2, and so on. And this is an iterative step, so it's possible also to go back and go forward. So in stage 1, this is something that all of you can do because it's quite simple. You have a list of ingredients or products, and you have the safety data sheets. And here you can find the intrinsic hazard property that are based on the CLP and REACH regulation of the European Commission. And the European Commission, in the Safe and Sustainable by Design framework, proposed 3 criteria to assess hazards. And based on those criteria, you can reach 4 levels of classification. So we have level 0 for most harmful substances, level 1 for substances of concern, and level 2 for other hazardous classes. And finally, level 3 for the chemicals that does not present any hazards. So this is, let's say, a first step of assessment. And this is an example. So we have a list of ingredients. We have the 3 main hazard classes that are human health, environmental, and physical hazards. You can check with the safety data sheets if an hazard is present or not, and finally classify according to the criteria proposed by the European Commission. We go forward, and we decided to assess not only the ingredients, but also the mixtures. So we have the list of ingredients, and then we apply the rules of the CLP classification that propose the additivity approach, and then we check if cutoff and concentration limits are reached or not, and we are able to identify the hazards of the mixtures, and finally to apply the classification that we had already seen. So in stage 2, we had to, let's say, construct a screening sustainability assessment, and we did it through a questionnaire covering all life cycle stages. So we have a raw material acquisition, production phase, the use phase that includes application and post-application, and the end of life. And sustainability is assessed by integrating information related to safety, functionality, and sustainability. So this is just an example of these questionnaires of the use phase, because it's the phase that is more interesting for you. And we have the 3 main aspects, as said before, and for each aspect we have several criteria. So, for example, we have the applicability range and the related question, that is, it is possible to apply the product solution on different substrates. And for each questions we have 5 levels of answers that I not reported, but by reply to this answer, it is possible to obtain a score from 1 to 5. And here you can see different levels of results. The main one is where we have all the criteria for all the life cycle stages and all the aspects. And here I reported an example where we have 2 innovative solutions compared to a benchmark. The benchmark is the reference, so should be a product that is already on the market and then we want to improve it. And then we have the results for life cycle stages and aggregated for sustainability aspects. Of course, those ones are more easy to understand. And finally, we came to stage 3, that is the last stage, for the life cycle assessment and life cycle costing. So this one is the last, and we are working on that, but life cycle assessment is an established methodology, is a tool for the analysis of environmental impacts related to a product, a process, or a service, along all phases of the life cycles. Here I represented, let's say, an example of a value chain of a product for the art conservation or restoration. Here you can see you should take into account the upstream, that includes the raw materials, the core, that includes the production, the downstream, that includes the use, so your work, and the downstream and the end of life. For all those stages, you should also consider transports, emissions, and all those products and processes that are involved in the value chain. So the life cycle assessment is a standardized methodology, and it involves 4 steps of assessment that are the goal and scope definition, the inventory analysis, the impact assessment, and the interpretation. So in the goal and scope definition, we understand, which is our case study, the system boundary, and also the functional unit. So if you want to assess 1 kilo of chemicals, and also the function of this product. In the inventory analysis, we are collecting all the information related to the product that could be offered by the partners, and in here we include also the use phase, so it is important also to communicate with the conservator that are using the product. And finally, we have impact assessment. Interpretation is a phase to try to draw some conclusion about our results. So for the impact assessment, we use the environmental footprint method, that is the method of the European Commission, that includes 16 impact categories. So here you can see they are illustrated. It is important to remark that when we talk about sustainability, it's not only one problem, like climate change, but we have several problems for the environment, such as toxicity for both human health and the environment, the use and the depletion of resource, mineral, metals, and fossil resource, the formation of particulate matter, water consumption, land use, land transformation, and so on. So it's a quite challenging assessment. And here you can have an example of this assessment. So we have 16 impact categories. Once again, we have an example for 2 innovative products and 1 benchmark. And here you can see that in this graph, at the 100%, we see the most impactful solution. Most of the case, it's the benchmark, even if just an example. The good things that you can understand with life cycle assessment is not only which of the solution performs better or worst, but also you can do an hotspot analysis. So you can understand which is the life cycle stages that is more impactful, which is the element or the process more impactful, and also you can apply another, let's say, normalization to understand which are the impact categories more affected by the production and the use and the downstream of your product. So, in conclusion, I just want to say that the GREENART approach is trying to support the early identification of safer and more sustainable alternatives. Now we are applying this approach, and we are the third and last stage of the assessment. And we can say that it helps to guide decision-making for both developers, and we hope in the future also for users like you. And also I would want to remark in the very end that stage 1 of the assessment could offer a straightforward method for assessing mixtures, hazards, and identify highly hazardous substances early in the process. And this is very important because the European Commission is trying to push to avoid, substitute the most hazardous substances, because they are not only not safe for human health, for workers, but are also substances that ends up in the environment and could be very tricky then to restore it. So with this, I finished, and thanks for your attention.
You can leave it for the next speaker. Thank you very much, Martina. As you can see from the program, the Q&A session will be at the end of each session before each break. So you can hold on to these questions. We will welcome them in a few minutes after we have heard from Manfred Anders and Katharina Schumann. Manfred specializes in paper, cellulose, and textile chemistry. He received his PhD on paper damaged by deacidification and consolidation at the University of Stuttgart. He subsequently held teaching assignments in Reutlingen and Hildesheim, and he has been a member of the IADA board between 1999 and 2007. And since 2002, he has worked in Leipzig as CEO and head of research and development at ZFB. I'm not even going to attempt saying it in German, the whole developed acronym. Katharina Schumann is an engineer specialized in printing and packaging technologies. She joined ZFB in 2015, where she researches active and preventive conservation products and process innovations. And Manfred and Katharina are going to talk to us about active, intelligent, and sustainable impulses for archival packaging.
Good morning. Thank you very much. I want to speak about the active intelligence and sustainable impulse in archive boxing packaging. So I just shortly want to speak about who we are. Zentrum für Bucherhaltung, long word. Then the benefits of packaging and the approaches which we did in the GREENART project, the construction, material, activity, and intelligence. So ZFB, we are a conservation center, so we do conservation mainly or nearly only for paper-based materials of archive and libraries. We have an own research section, so we have chemists, engineers, and also material scientists. So most of the machines we use in our restoration workshop are developed by ourselves and built up. Since 7 years, we also make packaging, especially for historic and archive materials and for museums, for example. We have a special section for disaster management, so we have large facilities for freeze drying, so if there's a catastrophe, we can dry all these materials. So in the packaging, there are different sections. So there's the standard packaging, so it's a standard box, but we have also the possibility of individual packaging. So you can measure your object, and then the box will be exactly in the size of this object. And we developed special modular packaging systems which can be very nice organized. Not the microphone. Okay, I will take it like this. And also things around of these, and we developed special boards for these boxes. So packaging have a lot of positive. Okay. So. Okay. Thank you. Packaging is very useful for protection of the item, especially against mechanical stress and damage, against dust, against light, soiling, environment impact, especially from the air. Also, it might protect against insects. It's mainly made, or normally because of the DIN ISO, it's made of fresh fiber with an alkaline reserve, and it's free from plasticizers and adhesives. And if you make individual packaging, you can really save space in your archive because it's just only the size you need for the box, for the item. And you have high stability, minimum 20 kilopascal load. So the conventional packaging has a lot of advantages. Especially it is a buffer of the climate outside and inside. So if you have a fluctuation of temperature and relative humidity, it is not directly in the box. So if it's all the time it's going up and down, it will be in the box in a smoother art, going up and down. So it slows down degradation process by this, and in the end it prevents restoration measures or saves restoration resources because degradation is not so fast. But what can we do better for the packaging? So smart green packaging, we try for the material to use sustainable resources. We try to get a better climate in the box, especially for the individual item. So the institution needs less energy for room climatization, and especially small entities, they have better possibility to store their items in a better manner. But how can we go to do this? First, we need to know what do we improve, also how to improve the box construction, which are the box's features which needed to optimize, what are the sustainable choices of raw materials, but also how can we make a better microclimate inside of the box. The way we go is, first we start with the construction, then we look at the materials, then we look, can we integrate some activity, and in the end, integration of intelligence by sensors. So we develop a greener active archival box. The microclimate, it's depending on the materials you have inside of the box, the need of humidity is mostly different. For example, bones, if you, in museums of natural heritage museums, if you store bones, they need a higher humidity, otherwise they crack. And other materials need very dry climate because it slows down the hydrolytic degradation of the materials. So the best is to have an individual climate due to the materials, buffering fluctuations, temperature and humidity, decrease the VOC, the volatile organic compounds, that there are no corrosive substances. And yeah, in the end, we want to have the best climate for the materials. So, for example, for the construction, how we went, we took first a conventional box. We put it in a climate chamber and put inside of the box a sensor which can measure the temperature and relative humidity and outside. And then we see the difference if we fluctuate temperature, or in this case, the relative humidity. We can see what is the effect of the box, how far can it buffer the differences. So first, we took the normal conventional box, and then we tried to make this box more tight. And this was done in several steps, and the tighter we succeeded to do the box, the better is the buffering effect. And we saw there is a possibility to reduce or to speed up the buffering effect as much as possible by sealing the whole board. But the substances until now we used for this, they have had too high volatile organic compounds emissions, so we are still looking for better solutions for the sealing of these materials. But by construction, we succeeded already to make the box much better. The next thing is to look for the materials, especially in Germany, and I think it's all over the world the same because of climate change. A lot of trees are getting critical. In Germany, if there is a storm all the time, a lot of old trees are falling. So now we have a lot of wood because all the dying trees are now for materials, we can have this, but in the future, we will get more and more problems. Still, now we see that we use much more wood out of the forest than it can grow up in the time. So for the future, we need other substances which are independent of the wood. And there, very interesting is to have fibers from annual plants like hemp, bagasse. Even agricultural residuals can be used to make paper out of this. So we have had a very close cooperation with the University of Applied Science in Stuttgart, and there they have a technicum where we can produce paper out of small amount of fibers. So we have had the possibility to produce different kinds of fibers and test the behavior of these fibers and these papers, and from these papers we can also make boards and look what is the behavior of boards and what would be the behavior of the box made out of these boards. So we produce different papers, and we saw the results as very promising. So we looked about does it meet the specification of the DIN ISO. We looked at acidity, alkaline reserve, VOC, and also, and this will be now the next, it's just ongoing, it's looking at life cycle assessment. The results is, we saw that if we say, take, for example, bagasse or hemp, these plants have much longer fibers, so we need to cut them down, otherwise they are too long for paper production, but we can adjust this length of the fiber due to our demands, and we can produce paper which has much better mechanical behavior. They are much stronger, and also the elongation are much higher. So it's very promising to do that. And the requirements of the ISO can be made, but the problem is still to find paper mills which can produce this one. Mostly we succeeded that you say, okay, is it possible to make one production of this special paper out of these fibers? They clean their machine, but still there are very small amount of brighteners, for example, left. So we see in these papers a very small amount of brightener is still in, because it's not possible to clean this paper machine so clean that there's nothing of them. But I think it's not the biggest problem of this. The biggest problem is, I already told that now there is enough wood, so the fibers are very cheap, and the fibers made out of hemp or other annual plants, in the end, we have a higher price because we need to produce, to find a paper mill, just make a special production. So in the end, the prices are too high. And until now, there are no standard products on the market. In the future, there will be, and we will see that then it would be possible to have better basis materials. And then we thought about, is it possible to use totally different materials? And we thought about polypropylene hollow chambers sheets, and there are different possibilities to make this. It's a conventional, made as from fossil oil, but also it's possible to take recycled polypropylene. This is problematic because you don't know exactly what kind of quality you have in the next day, because there are a mixture of many polypropylenes and additives, so it's not possible really to take this for heritage uses. But post-industrial recycling, there, if you take all the materials out of the production of one product, then it's possible to have a clear quality. And it's also possible to produce bio-based polypropylenes. So they are very interesting because they fix carbon dioxide inside of these materials, and it can be made out of sugarcane. This you can get from Brazil, or it's also can be made out of cooking oil, used cooking oil. And in the future, it will also be done by carbon dioxide and hydrogen made out of water. So we tested stability, flammability, emission, and also the life cycle assessment. The potential of this polypropylene is very interesting. It is absolutely water resistant. If there is a water disaster, these materials don't interact with the water, so it stays stable, and it's no problem to be inside of the water. And when we looked at the construction of the box, we saw if we make a sealing of the material, then the buffering potential is much higher. And this material can be sealed, or in itself it's totally sealed, so we have also a very good buffering effect. It's no insect food. It's also interesting. We have a longer protective function. We have a lower price. And even the CO2 consumption is possibly very low because we can fix carbon dioxide if we take the bio-based polypropylene or made out of carbon dioxide. So in the end, we saw mechanical properties are equal or even better. Both are flammable. We tested to add some flame retardants, but they are very expensive, and it's also a little bit problematic. Many of them have have VOCs we don't want to have. So still, there will be the possibility to develop this further on, but now it's too expensive in the end. So in the market, you will not be successful with this. Yeah, but it can be worked like on the cutting table, like normal boards. So the processing and the production of the boxes are totally the same. And we will see what the life cycle assessment tells us, because we think it's a very interesting solution. So now we want to put activity inside. In the Apache project, we already developed water-absorbing materials, so we can slow down the relative humidity inside of the box. In GREENART, we also developed, or our partners developed, aerogels or granulates or foams which absorb volatile organic compounds. One time on the basis of graphene, and the other thermals, they have a polyamine which also can absorb acidity and formaldehyde. To integrate these adsorbers inside of the box, we developed different possibilities to put it in the top or also in the walls. We can integrate the adsorbers, and they can be done in different forms. Sorry. And the intelligence, it would be perfect if you know what is happening inside of the box. So already in the Apache project, there was a development of a sensor which can be done inside of the box, and by your smartphone you can measure humidity and also temperature inside of the box without opening the box. So it's perfect to get an idea about the climate inside of the box. And so it's looking like that you can, if you go to the box with your smartphone, you get the results. In GREENART, we went the next step for our partners to use other materials for the antenna, which are more green. It's also, again, polypropylene, bio-based, or a cork. And in the end, if you look, there's the construction, the intelligence, the activity, but also you need to think about how to fix your item inside of the box, because this keeps this item more stable against mechanical stress. So there are many possibilities, especially, and this is the advantage of the possibility we use for the production, that we can design the box and immediately we can print it out the box, so we can see does the box fit the demand we do have. Thank you.
Thank you for teaching us that we can actually have archival boxes made from cooking oil. That's something we will try to remember and maybe ask you questions about later. So George Gorgolis' presentation will be made available to you tomorrow in the loop of videos that's going to be shown in the cinema room. But for now, our last presentation before the break and before the Q&A session will be made by Salvador Muñoz-Viñas, who is a professor in the Universidad Politécnica de Valencia in Spain and head of the paper conservation group of the university's Instituto de Restauración del Patrimonio. Along his career, he's worked as a paper conservator in the Historical Library of the University of Valencia, as a visiting scholar in Harvard University's Strauss Center for Conservation, or as a distinguished visiting professor in the Conservation Center of the NYU. His research work revolves around the theory of conservation and the technical aspects of paper conservation. And he will be talking with Maria Sobrino Estalrich, who completed her university and master's degree at the Universidad Politécnica de Valencia, and is currently pursuing a PhD in conservation and restoration at the same university. Her thesis research is part of the European project GREENART, her field of study focusing on the conservation of art on paper, and more specifically on new materials. Salvador and Maria are going to talk to us about a greener mounting system for paper artworks.
Hi, good morning. Well, thank you for being there. And I want to take this opportunity to express my gratitude to the whole GREENART team and to the whole team of the museum, because this is such a huge work. There is so much going on behind the scenes that, well, it deserves to be recognized. So here goes my gratitude to all of you who have made this possible. Now, okay, here we are. We will be presenting here a system for exhibiting paper-based artifacts in a nice, let's say, nice condition. We are going to address a problem. Our main intention, our main aim with this whole project was to improve the solutions to this kind of issues that so many museums have. I mean, how to keep a paper drawing, a map, a poster, whatever, flat and nice. That's a difficult thing. And the solution is usually to try to keep the room relative humidity within a very tight range. And that takes a lot of energy, and well, it's let's say it's not the most sustainable solution. So, well, you see, in order to solve these kind of problems, years ago we kind of devised a technique. It's a very basic system. That is, okay, yeah, you see, well, here we are boasting, saying that how well it works. And the interesting thing here is that this system is not a high-tech system, it's a low-tech system. We were looking for something that could be used in most circumstances around the world, and we are kind of adopting techniques that have been proven through centuries. We are adopting the Japanese, the Oriental, let's say the Asian paper-making techniques that are so well known in many paper conservation workshops, and we are kind of tweaking them to provide a system that will allow paper artifacts to be exhibited in pristine, nice condition. Now, here come, of course, we were thinking and working and speaking in Spanish, and we came up with the Sistema de Montaje Autorregulable, self-regulating mounting system. Now, if you take the capitals here, okay, this is what comes out, and it was, well, we were thinking, oh, what if we call this a smart system? Okay, we don't like to call this a smart system because it implies somehow that the other systems are not smart, and this is not something we want to imply. But in the end, well, this is how it has ended up being called. We are calling it, this is temporary, this is provisional, the smart technique. And the technique, is, those of you who work with paper conservation will recognize some of the idea, some bits of the idea behind the system. The technique is based on a base, which is a frame canvas, you know, regular plain vanilla canvas on a wooden plain vanilla frame, wooden frame, and nothing special. And here we are going to put the sheet on it. And the interesting thing is that we create a weak bond between the sheet and the canvas. And then in the perimeter, we apply a strong bond. That's it. That's the idea. Of course, there is much more to it. There are many details that will make it work or not. But, I will show you a real real-world how-to. So this is just a very fast set of photos of a example of this technique. One of the early version of the technique, because it has gone through many different versions, and it has been only under the GREENART umbrella that it has, let's say, become mature enough for dissemination. So you see, this is a map, 4 pieces of paper. We do the usual stuff paper conservators do. We clean the paper, we flatten it, we line it with Japanese paper, and then we are about to mount it. And the mounting system is this easy. We are applying, in this case, we are using a spray adhesive of some kind. It's not a special kind. This is how it looks, how the canvas looks, and then we mount the pieces of paper on it, and then we apply a strong bond to the perimeters. And in this case, we are using a very everything is quite sustainable, perhaps quite green, aside from the spray adhesive, which is not that bad either. And here we are using good old starch paste. Nothing special, and it works very well. It works like a charm. Now, when we started working under the GREENART umbrella, we had to go beyond pure experience, so we started doing some further, more in-depth testing, and my colleague Maria will explain it to you.
Thank you, Salvador, for the introduction. Thank you for having us here. I'm going to talk about, as Salvador said, about the scientific testing that we did under the umbrella of the GREENART project, because we wanted to understand how the system works and why it works, and the interaction between the different parts that we have. That's why we, for example, used IR thermography to understand the drying of the paper and how the paper reacts with different changes in the humidity, in the environmental humidity. These are some of the graphs made with the data obtained with the infrared thermography test that we showed before. And as we can see here, we have three different colors. They are different points on the same sheet of paper. So we can see, depending on the area, the behavior is very different. We also tested all types of adhesives, as Salvador said, spray adhesives among them, but much others. We did some strength tests with peel and shear test samples. We did also solubility tests in non-toxic solvents such as acetone and ethanol. And we tried different tools and applications. This testing was made on samples that were unaged, artificially aged, and naturally aged. As Salvador said, for this system, what it works is generally applied weak adhesion. We don't need a super strong bond. For the adhesive distribution, here as we can see on the screen, we did some SAM. We used it to ensure that the adhesive was not penetrating through the paper and it's just remaining on the surface, as we can see here. We also characterized every material that we used. We have a few examples here. We tested the hygroexpansivity of every one of them, testing at different relative humidities and then when immersed in water. This allowed us to compare the data obtained here with the performance within the system and also to compare one material to another. We also tested the interaction of the paper and fabric and the system itself with the environmental humidity. We put our samples into a 80 to 85% relative humidity environment, and we measured every 5 minutes. Then we put it back to the initial environment that was around 50% relative humidity, and we measure also every 5 minutes. The conclusions of this testing were that the dimensional change happens within the 15 first minutes of exposure. So these are some of the testing that we did, but we also tried different canvases, different raw linens, cottons, for example, different rigid bases, different tensions while mounting the canvas to the for the mounting, different arrangements between the machine direction and cross direction of paper and the warp and weft of fabric, different adhesives, as I said, conservation adhesives, spray adhesives, among others. Different relative humidity while mounting doing the mounting system. Different papers for the samples, and we also used posters that have half a century old. Different pretreatments both in paper and in fabric, different application techniques, as I said, and much more. Then I give the floor again to Salvador to tell us about some more examples.
Thank you, thank you. Yeah, we tried a lot of things, and yeah, it was a lot of work. But the result is that we have now polished the technique enough to show it here. We also understand it better than we did before, much better. But I must say that we do not fully understand the technique yet. Every answer we got resulted in at least 2 good questions. So, I mean, we have many questions still to explain why it works so well. But we have proof that the system works very well. It works very well in our exhaustive lab experiments, which are, well, we have made plenty of tests on a lot of mock-ups, medium to large size, as you can see here, with every kind of paper, including naturally aged paper, with these posters that look so much like from the 1970s. This is naturally aged paper, and it works. The system works, and this is the typical result. On the left, you have the smart system, okay, our system, let's go, and then we have another two typical systems used in conservation in museums and other centers, and the results are consistently better with the smart system, so that the need for a tight relative humidity range is relaxed substantially. Also, we know that it works in the real world, and I will show you a hard test, a very hard test. In 2017, we lined and prepared for exhibition about 30 posters from the 1920s, 30s, and 40s, movie posters, very large posters, one-piece posters measuring typically 160 by 120, and color lithographs. And we did the usual stuff. We lined them with Japanese paper, and then we mounted them with the smart system. And then they were exhibited in Valencia. Then the exhibition went to Madrid, the posters went to Madrid, and well, everything was fine when both exhibitions were over. And don't ask why, because I don't have an answer. But the posters were not stored in a nice place. They were stored in a regular, because of, well, it doesn't matter. They were stored here, in a storage facility for furniture. So there was no relative humidity control whatsoever. And so, well, the posters were left here. And in 2024, the GREENART people working with this went to check how they were. And we were surprised to discover that 5 years after being in these conditions, the poster looked like this. I mean, they were in pristine condition, absolutely flat, amazing. I mean, even for us, I mean, we were expecting good results, but it was beyond our expectations. You can see no wrinkle, no curling. This is a Spanish Civil War poster. And then I will sadly present you with an even harder test. And it has to do with the floods that happened in the Valencia region last October, which were dramatic. And the bad thing was really this, okay, and the 2,000 people who died. But this storage facility was also flooded. I mean, it was covered with like about 1 meter of water. And it remained inaccessible for the rescue teams for about 10 days. So the posters remained in water and in a place with muddy water for about 10 days. Can you imagine the conditions? The relative humidity conditions were, let's say, not the best. And well, finally, 3 weeks later, when we were called to check what had happened, well, we discovered that the posters, well, the part that had been underwater was, as you can expect, damaged and distorted. It had unstuck. But the part of the poster that had not been wet with liquid water directly was surprisingly flat. And this is, I think, proof that the system works. And it now works better because of the work we have done within the GREENART project. And well, there are plenty of details here, but we cannot show them to you, but we are planning a hands-on workshop for conservators that will take place in Athens. And if you are interested, you can email the organizers here. It's a part of the GREENART project, so you are all invited. And here we are, Maria and I, but there are other people who have worked within this project. And so we hope that you have found this interesting. We are so glad to share our findings with you, and ready for answering any question you may have. Thank you so much.
We will now start with the Q&A session. The wonderful security agents, welcoming agents are ready with the microphones. So if anybody wants to raise their hands and have any questions for our panelists today. Bear in mind that from where I am, I see very badly, so yes. Merci.
Good morning. Thank you so much for the organization and the presentation itself.
May I please ask you to introduce yourself?
Okay, well,
Yes.
my name is Daniel Aguilera. I work at CY Sergi University, Sergi Paris University. I am an associate professor in that university. I am working with a PhD program related with foam storage for museums. Sorry, because I learned these words in French, so to translate it in English. So that's the reason why, with some colleagues, we are here interested in this public training. I think I go for the questions. I have a first question for the first presentation, that is Martina Menecaldo. I would like to know what the difference between stage 2 and stage 3 in terms of the evaluation of the end of life, because I don't understand if there are a big difference between the evaluation in the environmental impact between both stages. For me, it's clear for the stage 3 is the life cycle assessment, but for the 2, it's not so clear if there are environmental evaluation or not, or what is there are a nuance in the difference. Mm-hmm. This is the first question. And the second question, is more technical. When you were doing the life cycle assessment, what kind of, how did you get information for the inventory step? It was more database of you have to call the people you understand what I mean?
Yeah.
Because, thank you.
It's clear. Thanks. So the first answer is that the difference between stage 2 and stage 3 is that in stage 2 we have a screening sustainability assessment. So we have some general questions related not only to sustainability, but also to safety and functionality. Sustainability, we have some questions also, not only for the environmental sustainability, but also social and economic. So it's a more screening level. So it's just to give you an idea to the partners if they have some hotspot. So if something is working bad or it's working good. In the life cycle assessment, indeed, it's well-established methodologies. So in that stage, we are looking at the environmental impacts. So it's more quantitative and objective evaluation. And for answer at the second questions, the data were obtained through dedicated questionnaires that we provide to producers, but we are also using some databases that are dedicated for life cycle assessment. So those are commercial, so you need to have the assess. But the Environmental Commission is developing also another database that is the results of the European projects. So this is another way, let's say. And also, of course, literature, because in papers that are published, you can find secondary data that could be also useful.
My name is Alessandra Cama. I'm studying paper conservation at the Central Institute for Pathology of Books and Paper in Rome. And I used to be, in my previous life, a board director, still a board director, managing director, a group of companies, and we had, one of them was the biggest supply chain company in paper transportation. And I had also in the group a company, organic food company, doing organic food with grass-based packaging. Therefore, I have one question for Manfred on that grass paper. I have one question for Martina on the supply chain of paper and your LCA. And I also have a question for Salvador, more a technical question, because I read your book and I really like your very practical presentation today. So the first one for Manfred. I shopped around because I was confronted in the first year with how to store in a sustainable way paper. And I shopped around that you're quite expensive, especially for Italians. I was based in Germany and still for German. So how can you reduce the price of those solutions? And what I was thinking is, I had in that company also grass-based paper without bleachings, with organic standards for food, which was much cheaper than your products. You can imagine produced in an industrial way. And I was thinking, have you explored efficiency measures to decrease the prices of your solutions? This is the first question. I would go to the second question and then to Martina, and if you prefer, and or no, maybe it's better that Manfred answers.
Step by step.
Yeah, step by step.
I can say for Germany, we have the ISO standard, and the ISO standard, there's an ISO standard A and B. The ISO standard A is without any lignin. And in Germany, all institutions are only using standard A without any lignin. So the production of these fibers is very expensive. And all the time we are looking how to make things cheaper, because concurrence is very hard, especially in Germany. I think it's everywhere though. So if we see a way how to get a cheaper price, we try to do that, because then we are more successful in the market. But the quality standards which we need to meet bounce us in the end. And we have had very often discussion about that. Is it really necessary that we don't have any lignin inside? There's also another possibility, for example, to make a board with lignin, and the surface which is in touch with the object is a paper without lignin. But all these solutions are not successful. People want, if they spend money for boxing, then they said, we want to have the best. So in the end, the demand and the ISO standards forces us to take very expensive ground materials. And we try really to get the best paper for the cheapest price. Then we produce out of these papers the boards, and there we look again to have the best construction, that we can have the highest stability with less of material, so we optimize the weight, the amount of fibers for stability. You can make, especially in the corrugated board, if you think about the construction, you can optimize this. We do that. So we try to do our best, but in the end, prices are high. If you look for packaging in the normal sector where we can take normal boards with lignin, prices are much cheaper because you don't have such a lot of processing inside, because the extraction of lignin takes a lot of water, takes a lot of energy. In the end, you have less fibers because you have an extraction about 35% of lignin, but you also extract some of the cellulose. So in the end, you have only 50% of the fibers after this process. So if you look at this, only this without the process, it's doubles the price. So in the end, it's the ISO standard which forces us to take this paper. And our idea and also our hope was that if we look for agricultural residues, for example, or grass, very often this materials is not used. So we thought perhaps we can get very cheap the raw material and can process this, but in the end, it was much more expensive because you spent a lot of money for the logistic, because the density of these fibers are much more low. So you need to collect, and you have a lot of volume to transport. So in the end, it's not so easy if you want to have a real green product to get this. But I think in future there's a process ongoing, because now wood is cheap, but in the future it will get in the price higher because will not be so much like now. And so in the end, we need to have other better possibility, greener possibilities, but now on the market, they don't have any chance.
Thank you, Manfred.
I
Go
speed
on
it
with
up.
your
I will go to the Salvador, and because Martin already had the questions. I have a question related. In this case, I'm really a newbie on the mounting, but the first things I learned from restorators were it needs to be flexible. And I even experienced during the visit of one of the restorators that I visited that he was demounting with a lot of effort an Innsbruck map, town map, huge, from a very unflexible system. And I was thinking, well, you had 5 years experience, but what about the 100 years experience of having paper mounted on very rigid systems? Have you, of course, you had the stress testing of the dramatic Valencia cases, but what's your study on that?
Well, yeah, I think we have experience with those old 9th century maps mounted on canvas. But we don't have that much experience with paper mounted on rigid surfaces. That's something we don't, we have not worked with. But it may be interesting to note that this system is not rigid. We have tried rigid surfaces. Maybe we have thought maybe this system will work with a totally rigid surface, and it doesn't work. We need somehow flexible surface. The interesting thing is that paper behaves in an opposite way to canvas. So they counteract. When paper wants to shrink, a canvas wants to expand, and they counteract as long as they are bonded with a weak enough adhesive. That's the key. That's the key, and it's very beautiful to see how the paper remains flat on the surface, but on the other side of the canvas, the canvas is wrinkled, but the paper is flat, and this happens because the surface is not rigid. We don't want to have a very rigid canvas with this for this to work. Mm-hmm.
Thank you very much. I saw some other, many hands raised in the audience. Please raise them again. That's weird. Sure, go ahead. Otherwise, I have a few questions. Go ahead with the mic, because it is recorded.
Sorry, it's because by continuing my presentation, we also work in a laboratory of polymers, so maybe the question can be a little bit technical. So I have a question for the exposition of the packaging, Manfred Anders, if I am don't pronouncing well. So I would like to know, because it's not clear for me, what is the function of the lignin in the packaging? So they helps to improve the mechanical properties of. We desire in a packaging that lignin is present on only pure cellulose. So this is one question. I don't know if it's clear my question or
The bots?
Yeah.
Oh, they are made out of pure cellulose, yes. Because according to the DIN ISO, we are not allowed to put lignin, or so it's pure cellulose paper.
Okay.
And there is also a minimum alkaline reserve of 2% of calcium carbonate.
Okay, but if it's present, for example, if you use waste for, I don't know, woods and whatever, if they are present, they can affect the mechanical properties of the box or
So the ISO standard said pure cellulose, calcium carbonate, and if you produce a fiber like this, you need a chemical process for the extraction of all the lignin. Mm-hmm. So you have, and there it is, yeah. In the end, if you have as a basis wood, and it depends, it's only the pure wood or also waste of wood, the same process as working on this, and you get same cellulose, and the cellulose fibers are only different because due to the kind of wood. If you have what's the English name of this? If you have
Softwood or hardwood?
Softwood and hardwood, this is the one difference. On the other side, if you have leaves, trees with leaves, and the other one with needles. If you have the needle tree, they have longer fibers, so the pure cellulose has longer fiber, and so you have better mechanical behavior of the board made out of this.
So I have another related question. So it means that longer fibers is better for mechanical properties.
Yes.
But I understood, or I heard in your presentation, that you were also trying to decrease the size of the fibers, if I understood well.
So if we take the wood, we are in the system, we only can adjust the fiber lengths by the kind of wood we put for this. Mm-hmm. But if we take annual plants like hemp or something like bagasse, the fibers out of this, it's very easy to extract the lignin, because the lignin content is much lower. The lignin is not so much cross-linked, so you can very easily extract it only by alkaline cooking. It's much ecologic friendlier, and you don't need so much water and energy. And in the end, you have a long fiber. The fiber is much too long that you can make paper out of this, so you need to cut it down, depending your paper machine you have, because normal paper machine only can produce paper out of fibers up to 2 or 3 millimeters. There are some other machines, they can work with up to 5 or 6 millimeters, but then you cannot make it longer, otherwise you get problem. It is not even the paper.
In the split problem, that it's not possible to do a good dispersion when the fibers are so long. The problems are mainly for the initial suspension is so hard, the viscosity is too.
The problem is if the fibers are too long, the fibers are getting together in knots. So if you want to make the dispersion on the
surface,
sieve, then you have an uneven paper. Especially Japanese paper, they have a special technique how they succeed to have longer fibers and to produce paper out of this. And the longer the fibers is, you are also able to make very, very thin papers or stabilize.
Okay, last question, I promise. It's not because we are working in something similar, so for the reason and how to cut the fibers, because myelin or
it's a mechanical by a guillotine. You're putting there, and then it's want to cut down.
Maybe I'm going to look for you in the lunch break to explain me better. Thank you so much.
In the lunch break, Manfred will not be available because he will be having lunch. However, at the coffee break, you can have an extra long class on paper making and industrial European paper making. Do we have one last question for the panelists? There's one here. Juste là. Pardon. Ah, pardon. So we can have two.
Hi, my name is Paula Gayer. I'm a photograph conservator based in London. My question is for Maria. I was wondering, because you mentioned that you have tested a lot of materials, and I'm guessing you have taken into account that they were sustainable, so they were not bad for the environment, but I was wondering if you took into account if they were accessible to people, if they were available, so if they were sustainable to be used on the long term, but many institutions. And if you did take that into account, how did you tackle it?
Sure. As Salvador said, our main point was that the technology was low-tech. The materials were easy to buy everywhere. We used, for example, raw linen that is mostly available everywhere. We used the wooden frames. We used starch. And we ended up using a conservation adhesive. So yes, we thought about it because we wanted this system to be used for everyone. And we know that sometimes institutions don't have lots of money to spend on these kind of things. So yes, thank you for the question.
We have one last question. Sylvia?
Sylvia Brunetti, paper conservator in France. I have a question for Salvador about the adhesives you have used. You said you used a spray, that you tested other kinds of adhesives. Could you say why you made this choice?
Well, that's a fast, easy question. Lascaux 303 HV, which, well, you know, it's water-based. It remains sticky at room temperature, and is very easy to handle, and is well an approved conservation adhesive, and it works very, very well, very well. That was one of the key findings of within these 2 or 3 years of hard work with the system. Mm-hmm.
Thank you very much. We'll now go into coffee break and long discussions. It's a 20 minutes coffee break, and the coffee break happens behind these curtains. So you need to go up and then all around the auditorium, and in the back you'll find coffee and cookies.